let's talk about graphs. Now, these pieces of the graph, I'm warning you right now, on the 1050 final, they're pretty picky about. So please take very good notes on this section. For this next video, we're going to be focusing on this graph right here. Now, let's talk about some definitions. First, we have increasing. What they mean by increasing is as I move through the graph from left to right. Actually, I'm going to do that in blue. So I'm going to go from left to right. I follow the graph, and if I'm going uphill, then I'm increasing. If I am going downhill, I am decreasing. And if I am going flat, then I am constant. So I start over on the left. I'm going to follow the graph, and I look, okay, right here, this is increasing because I'm going uphill. This next spot, I am decreasing because I'm going downhill. Next spot, I'm going increasing because I'm going uphill. This part is constant because it's flat. And then I have increasing uphill. So hopefully you can see that I'm going from left to right, uphill, downhill, uphill, flat, uphill. That's how we tell those. Now, how we list our answers. A couple of things you should take notes on. Number one, these answers are going to be intervals. So like from this point to this point. Another key thing for all of these, we always use x values in those intervals. So let me show you what I mean by that. This first increasing interval right here, it goes from this point to this point. I want to use the x values of those points. So I want to say from -4 to -2. That's increasing. So from -4 to -2. Those are the x values for which it is increasing. Now, because this is an interval, I can use parentheses to not include it, or I can use brackets to include it. So this I'm going to tell you right now, anytime you're doing increasing, decreasing, constant, it is always parentheses. You do not do brackets. Now, the explanation for why we don't do brackets kind of gets into a little bit of calculus and the definitions of increasing and decreasing with limits and all that jazz. So for now, don't worry about it too much. Just know that we always do parentheses. So we're going to go parentheses from -4 to -2. Now I'm going to look at my next increasing section. So that's right here. Goes from this point to this point. Remember to use x values. So from x is 3 to x is 4. So from 3 to 4, and always do parentheses because that's what we do for increasing, decreasing. My last increasing section is here. From this point to this point, use our x values. So from 5 to 6. Always use parentheses. And I just did commas to separate each of my intervals. Okay, let's do decreasing. I only have one interval that is decreasing. That's right there. From this point to this point. So once again, pick out our x values from -2 to 3. And always parentheses. Now, this can sometimes be confusing because you think that this is a point, like x comma y, -2 comma 3, like a point. It is not. It is an interval. This is an interval, not a point. So from x equals -2 to x equals 3. And our last one, our constant, is right there. So from x equals 4 to x equals 5. And there we go. That's how you do increasing and decreasing. Next, let's do our definitions of maximums and minimums. Now, we have two types of max and mins. We have our local max and min, which is a maximum and minimum point locally. So AKA, the way I remember it, is a local max is a point higher than the points around it. So essentially we're looking for a hill. So we got a hill like this. That's our local maximum because it is higher than all the points around it. Same thing for a local minimum. It's a point that is lower than all the points around it. So AKA, we're looking for a valley. Something like this, where that bottom point is lower than all the points around it. Now, compare that to an absolute maximum. An absolute maximum is absolutely the highest point on the graph. The highest. And when I say point, I don't really mean point. We usually do y values. The highest y value on the graph. And same thing for an absolute minimum is the absolute lowest y value on the graph. So, something to note. We can have multiple local maximums and minimums. Let me give you an example. I have this graph that looks like that. All of these are local maximums. All of these are local minimums because they're the hills and the valleys, higher than the points around it, lower than the points around it. However, the absolute highest point is there, and the absolute lowest point is there. So there's our absolute max and our absolute min. You can only have one absolute max, one absolute min. So let's go back to this graph here and find our local max, local min, and actually we're going to do these ones as points. And then our absolute max value. Value is saying we don't want the whole point. We just want the y value. And the absolute minimum y value. It's absolute min value. So, for local max and min, I am looking for my hills and valleys. So, I've got a hill there. Do that circle. Woo! Too big. There's my hill, so that is a local max. So I'm going to come here and put the point, -2, 4.5. That is the local maximum point. I don't see any other hills in this graph. So local maxes, we're done. Local mins, that's our valleys. I see a local min, a valley right there, lower than the points around it. So that point is at 3, -8. That's my local minimum point. I want the whole point, it's the valley. Now let's look at our absolute max value. So that is absolutely the highest point on the graph. Looks like that is the highest point on the graph. And value means I want the y value of the point, not the whole point. So we're going to say 5.5. That is the absolute maximum y value on this graph. And the absolute minimum y value, that is right there, absolute lowest point. And again, we want the y value, so that is -8. So hopefully that helps you clarify increasing, decreasing max and mins. We have one more video to go where we're going to put everything we learned this lesson together in one final example.